All right, we are now doing the 8B notes. 8B notes will be split into several parts. I don't know if it's going to be 3 or 4 parts, but obviously this is the first part. We're going to try to get up through up to the divide and simplify. That's where we're going to stop this time. All right, so we're going to simplify by factoring, or I like to call it pulling out the perfect squares. Now, on your TI-30XS multiview, you could literally type in the square root of 20 and it will give you the answer of 2 square root of 5 is what we're looking for. Now, if you look at the next question, there's a variable in it and the calculator will not do variables whatsoever. And it will not do cube roots, which is the next section right there. So we really got to understand how the calculator gets this answer. If you have your multiplication chart, you're trying to look at perfect squares first. 2 squared is 4, 3 squared is 9, 4 squared is 16, and you're starting getting the pattern here. It's really that one diagonal on the multiplication chart. So I'm looking to see if anyone does 4, 9, 16, 25, 36, and of course it is, etc., etc. It goes up truly infinitely. We're not going to have to worry about too big of numbers. But if I look at 20, 20 is definitely the square root of 4 times the square root of 5. Now I like to do a silly thing called the good guys and bad guys. I put the good guys in one square root and the bad guys in the other. When the good guys are in the square root of 4, they escape the radical. So it's 2 root 5. And there's my answer. Now, this next one here, the square root of 16x to the 16th. I always like doing this because this is weird because I'm going to do the square root of 16 twice and I'm going to get different answers each time I do it. Now the square root of 16, we know the square root of 16 is equal to 4. Now the square root of x to the 16th, remember there's an invisible 2 and we do, remember this is the denominator, so it's 16 divided by 2, so this is x to the 8th. So really this is just 4x to the 8th. And to be honest, I really wouldn't do any of these steps down here. I'm just trying to overemphasize. Exponents are treated differently than regular numbers. Whatever this index is, in this case 2, if this is an even index, 16 divided by 2 does work, so that is a perfect square. So if I were to do something like the x to the 10th power, just make up a question. That is an even x, 10 divided by 2, so that is x to the 5th. So 10 is a perfect square as an exponent in this question, but if I were to do the square root of 10, that is not a perfect square and I can't do anything to it. Okay, exponents and numbers are treated differently. So now this one, 54x to the 6. Well, I know the exponent's even, so that's a perfect square. So if I make my good guys and my bad guys, now what perfect square goes into 54? Well, 9 does. So square root of 9 is here, and the bad guy is 6. Now, 6 is a bad guy here for a regular number, but exponent is good, so I'm going to put in the good guys. So, square root of 9 is 3, 6 divided by 2 is x to the 3rd, and then the square root of 6 just stays there. Alright, so we got 2 issues here. First of all, we have our first odd exponent when we're doing a square root. 7 is not divisible by 2, so we have our first problem here. 72 is also not a perfect square. But there's also an interesting look at this. If I look at 72, 72 is divisible by 9. Okay, so I could pull out a 9, but if I look closer, 36, 72 divided by 36 also works. And I always want to pull out the biggest perfect square. Now, if we do miss it, we will still find it, but it's always easiest to find the biggest one. So I'm going to break this into the good guy. That's 36 times 2. Now, what is the highest multiple of 2 that is under 7? That would be 6. So I'm going to split it x to the 6, x to the first. Now again, I don't really need to write that one, but I'm going to overemphasize it because 6 plus 1 is 7. So when I do the square root of this, the square root of 36 is 6. The square root of x is 6. 6 divided by 2 is x cubed. And then it's just the square root of 2x, and that would be my answer. So that's squares. The next question here, I'm going to change my color here, my pen. We're going to be looking for perfect cubes. Now we'd make a little chart here. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And I'm not sure about the rest, but if you need it, then you're going to have to work it out. And you really have to guess and check. All right, so now this first one, 27, well, I know that's a perfect cube because that's what 3 cubed is. So now, is 12 a perfect cube when it's an exponent? Well, I do my exponent divided by the index. 12 divided by 3 is 4. So 12, any multiple of 3 is a perfect cube. So the cube root of 27 is 3. 12 divided by 3 is x to the 4th. And that is done correctly. They're both perfect cubes in there. Now 56 is not a perfect cube. But if I look at this, 8 does go into 56, but 27 does not. So 8 is going to be the perfect cube I'm going to pull out this time. So I'm going to have good guys, and I'm going to have bad guys. So 8, since 8 is the good guy, 8 times 7 is 56. Now 10 divided by 3 does not work. But what is the highest multiple of 3 that is the closest to 10? And it's got to be underneath it. So 9 is a multiple of 3, so I'm going to break this into y to the 9th and y to the 1st. So cube root of 8 is 2. 9 divided by 3, that's y to the 3rd. And then the bad guys stay in the cube root, so it's just 7y. And please don't forget to type in the cube root on this. I'll see a lot of times you'll have it done correctly on the paper, but somebody will just forget that. So you got to be careful. The next cube root. Now 128 is not a perfect cube, so I got to split it up. And you notice 8 does go into it, but you really, again, you want to pick out the bigger one. 64 goes into 128 as well. So if I have my good guys, cube root, bad guys, cube root. I'm right, cube root of 64 is a good guy, and 64 times 2 is that. All right, so now 17 divided by 3, that does not go evenly. So what's the highest multiple of 3 that's under 17? Well, that would be 15. So it would be 15 plus 2 is 17. So I'm going to make x to the 15th here and x to the 2nd here. Now this is one where, you got to be careful. I'll see 8 written on this one all the time, but the cube root of 64 is 4. I know the square root of 64 is 8, but again, we're doing the cube root, not the square root. 15 divided by 3 is x to the 5th. Cube root, and these are the bad guys, so they just stay inside the radical. It cannot simplify. All right, so we've done squares, we've done cubes. Now we're going to do a variety of different things. We're going to do fourths, fifths, etc. So, again, we got to look at this one. This has got to be a 2 because 80 is divisible by 2. What's 2 to the 4th? 2 to the 4th is 16. Does 16 go into 80? Yes, it does, 5 times. So we're going to have our good guys, our bad guys. So 16 is a good guy, 5 is not a perfect 4th. Is 15 a multiple of 4? Well, no, it's not. What is the highest multiple of 4 that is closest to 15? The answer is 12. 12 plus 3 is 15, so I'm going to put x to the 12th, x to the 3rd. So, when I do my fourth roots, the fourth root of 16 is 2. 12 divided by 4 is 3. and the bad guys just stay inside of here. Alrighty. Alright, the fifth root. Oh my goodness. Now we got to look at 2 to the 5th, which is 32. 32 does not go into 243. 3 to the 5th, when I type that on my calculator, oh, I get 243. So actually, 243 is a perfect fifth. So again, if I do my good guy, bad guy, fifth root, and eventually you'll probably want to skip my good guy, bad guy. But again, I'm trying to show you how I'm thinking through the question. The fifth root of 243 is 3. Now, is 12 a multiple of 5? No, it's not. But I can break it into 10 plus 2. 10 is a multiple of 5. So I'm going to have x to the 10th, x squared. So, and I meant to write 243. I wrote the answer in there. Okay, so it is, let me draw this a little nicer in here. This is 243 under here, because 243 is a perfect fifth. The fifth root of 243 is x. 10 divided by 5 is x squared. And then the bad guy just stays in here. All right. Now we're going to go back to square roots, because we're going to be going all over the place. There's nothing written here, so again, remember, there's the invisible 2 there. Now, I like to do good guy and bad guy again. Square root, square root. Square root of 20. Well, 4 goes into it. I know that's a good guy. And 5 is a bad guy. Now, a, that does not have anything. It doesn't have up to 2. It only has a 1. I cannot do anything, so that's just going to stay in the bad guy zone here. Now, b cubed is bigger than 2, so I can split this into b squared, which is a perfect square. Then b is not. Now, c squared is a perfect square, so I'm just going to put that in the good guy. So now I square root all the good guys to get them out. So it's 2bc. Then it's the square root of 5ab. All right. And so that's all we need to do on that one. All righty. Multiply and then simplify if possible. Lots of different ways of doing this. Some people, the calculator will do this one. Some people like to break it up a little and start thinking beforehand. Several ways. 5 times 15 is the square root of 75. And if you think about it, square root of 25 times the square root of 3, which is 5 radical 3. And that's how you would just look at that one. If I were to look at this a slightly different way, I could look at the square root of 5, and this is the square root of 5 times 3. So I'm just looking at the factors. So if I see that, I can instantly see 5 times 5 is 25, so that's got to be a good one. That's got to be bad guy, and I get the same answer. Really depends on how you think about it. If the numbers get big, I definitely like to do it this way. If the numbers are small like this, it's really up to you on how you want to handle this. I would look at this one and think this is 2 and 3. Now, if you notice, I have 2 3s here. So the good guys, 3 times 3 is 9. And then I have the 2, so the 2's got to go over here. So if you notice, 3 times 6 is really 18. But the perfect square of this is really 9 times 2. That's how I'd want to split it. Now, x cubed is by itself here. So now that is not. So I'd really want to break that into x squared and then x. Now, y to the 8th is a perfect square, so I would just leave that together. So now I do my square root. That's going to be 3. 2 divided by 2 is x to the 1st. 8 divided by 2 is y to the 4th. The bad guy just stays inside there. Now, if you notice, we have the same index, so we're okay on this. So we can do this. So this time, I'm looking at 9 times 3. Well, that is 27, so I know that is a perfect cube. How about z squared times z to the 4th? Well, that's z to the 6th. Is 6 a multiple of 3? Well, yes, it is. Oh, well, hey, this is a great question. They're both perfect cubes. So I just go cube root of 27 is 3. 6 divided by 3 is z squared. Alrighty. And really, we just have these 3 questions here. That's the end of this section here. This first one here, the numbers are big. So I would definitely look at this, split this into 9 times 7. And this is 9 times 3. So now again, we're looking at perfect squares. So if I do this, good guy, bad guy, I'm going to take the 2 9s, because 9 times 9 is 81, and that is a perfect square. This is a 7 times 3. 21 is a bad guy. It's just not going to work. Now I look at a to the 9th and a to the 10th. That's really a to the 9th times a to the 10th is a to the 19th. Now if I'm looking for perfect squares, what is the highest multiple of 2 that is under 19? Well, that's 18. So I can split this into 18 plus 1. So I'm going to write a to the 18th, a to the 1st. Now b and b to the 8th. So b times b to the 8th is b to the 9th. Now I know 9 looks like a perfect square because 3 times 3 is 9, but remember this is an exponent. This has to be divisible by 2. 9 is not divisible by 2. So I'm going to write this, almost go right back to where I was, isn't it? 8 plus 1. So it's b to the 8th, b to the 1st. I squared of 81, that's 9. 18 divided by 2 is a to the 9th. 8 divided by 2 is b to the 4th. Then these guys just stay inside the square root. These are where it gets tough. These get very difficult. These have different indexes, so that's where we're going to have to go back and use rational expressions. Remember, the index is always the denominator, so this is really c to the 4/5 power. Okay. And this is going to be times c to the 3/2 power. Now what's nice about this, when I add them together, I just have to add those fractions together. When I add them up, I get 23 over 10. So if I want to write it back, it's the 10th root of c to the 23rd. Now, 23 is not divisible by 10, so I want to split this into 20 plus 3. So the c to the 20th, 10th root of c to the 3rd. 20 divided by 10, so that's c squared, the 10th root of c cubed. Sheesh! Now the first thing I notice on this 8 is really 2 to the 3rd, isn't it? And so that's a key thing here because this is the base, that's a 2 as well, isn't it? So if I multiply these together, 2 times 2 to the 3rd, if I add the exponents, that's really, whoops, forgive me on this. It is still 2 to the cubed, that's correct. But I have to, these are different indexes, so I have to really do 2 raised to the 1/2 power, x raised to the 3/2 power, y raised to the 1/2 power, times, since 8 is really 2 to the 3rd, this is really 2 raised to the 3/4 power, x raised to the 1/4 power, y raised to the 2/4 power, which I could reduce to 1/2. So now I'm going to multiply. The bases are the same here, so 1/2 plus 3/4. If I do this on the side, 1/2 plus 3/4 is 2 to the 5/4. If I do this next one here, x 3/2, put 2 lines under this, 3/2 plus 1/4 is 7/4. So this is x to the 7/4. Now this is the first good one here. 1/2 plus really 1/2, that's 1 to the 1st power. So hooray, that's already settled, right? So I know there's a y in my final answer. Unfortunately, these other two are not. But luckily enough, they have the same denominator. So I could rewrite this as y on the outside, then the 4th root of 2 to the 5th, and x to the 7th. So now both these numbers are bigger than this, so I'd really want to break this up again. Fourth root of 2 to the fourth, fourth root of 2 to the first, and so this will be x to the fourth, x to the third. So then the y just comes down. These are my good guys. Well, 4 divided by 4, so that's really 2, and that's y. 4 divided by 4 is x, and then it's the fourth root of 2x cubed. Now you can write the y and the x in any order you want to. I really could have written 2xy because they normally will write it in alphabetical order. All right, so that is a very tough, very difficult section. I expect lots of questions on this, and that's about 20 minutes, one of my longer videos, but we're going to stop now.